key thing here to remember is we need to follow this red-green refactor that we have to ourselves be aware of following these things. So here is our requirement. So we need to write a class which has a method convert where it accepts a number which is of type int and it returns a value respective Roman numeral string, which returns a respective Roman numeral string. So to give an example, when we give an 1, it should return I. I'm calling it as I. I'm not sure how to call that Roman. What? 1. Okay, Roman numeral 1. Yeah. So in some ways, we have this much. So I'm an iOS dev. I'm going to do that in Xcode. If you want to continue with me, I think you can have your laptop. I mean, you can do the same thing in your own language. Is anyone interested? Yeah, fine. What about you, Shubham? I challenge you to do that. Post kata. Post kata. Man, Ashok, please. Laptop. Oh, you don't have a laptop. So I'm going to create a new project. And I'm going to open this project as a framework, create this project as a framework because so that it doesn't have to run every time as an app. It's just for a Java folks, it's just like a package, Java package. So I have also included unit test. So this is the 5th time I'm actually doing this test. I mean, I'm taking this kata. That is the real thing we have to do. So we have to follow the same kata. I mean, we have to do the same kata for the 5th time or n times, so that it will automatically get into our muscle memory. Let me delete all these previous things. So what is our first stage? Test. Okay, let's create a class. So as our requirement is to have a method, so create a class which has a method. So I'm going to follow the same thing here. So command says function test. So for our first stage is to write a test, failing test. So for that, let sut is equal to suit under test. Which will obviously be failing, as you can run. Yeah. So this is considered as a failure. As Uncle Bob said, compilation failure is a failure. So I'm going to write a production code for the respective test case. So in Xcode, we have to import that package into our test suite. So for that, I have to do something like stable import Roman numeral kata. So this whole package is what I have imported here. So whatever classes that I declare here or whatever file that I declared here will be available for me from this package. So still we get this as a compilation error. So let me confirm it once. I have to write let me run the. So build succeeded. Then this has to be a public class. I'm not sure why it was compiling. It shouldn't be compiling. This has to be a public class. Anyway. Here I'm testing whether it is a nil. It should not be nil. The test succeed. And here we say that the requirement says that we should have a function called convert, and that should get an integer. So let me write a test case for that. Test for that. Assert equal sut dot convert. I'm going to give 1 as a number, and I'm expecting, what is the expected output here? Roman 1, yeah, 1. So, so it's giving me an error, showing me again. It's showing us a compilation error that the method is not there, right? So we have to write a method for that. And it should return me a string. Function. Forgot to write the function. So when I try to run here, it actually this compilation error uh, shouldn't be like popping out. Yes. Convert. Yes. Yeah, yeah. Yeah, that comes when we are going to refactor now. So that will be the next action that I'm going to take as a refactoring step. We don't need that SUT not nil actually. So what is the minimum code that I have to write here? Just return. That's right. Just to make this test pass, I think that is enough. Yeah, test succeed. By the way, I think we don't need this test now. We don't have to. So we are in a green phase. What is the next phase? It's a refactor phase. So I'm going to refactor the test here. That just going to delete this, which is not needed now. But then. Yeah, that's the only solution that I had. So the extreme folks, the way they do it is they start with SUV.convert. Okay. And then you don't have any conversion. Okay. So you start writing out what is SUV. So it will be let SUV equal to Roman numeral. Okay. Then you go and then write the class for Roman numeral. Yes. And you don't have convert in them. So then your program gets compiled. And then you go about doing that. So that's the extreme way of doing it, where you actually start with the design spec in mind. Okay. Because if you look at it, the one deviation that you have taken, I mean, there's nothing wrong with this, of course. You initially ensured that there is a class that was defined, and you ensured that your test case passes for that class. But if you look from a design spec standpoint, your design spec was, if you look at it, your spec was for convert. Okay, got it. So we should start with the end in mind. So, like, you have started with convert, yeah, then you would gradually improve on. Because now you add a test case and then you remove the test case. Yes. When you add an assertion and you remove the assertion, yes, which is the actual part of it. So our obvious next case is next test case is like to test for 2. So the expected output is 2. So what could be the if number, the shortest way in doing this thing in Swift is this is 2. Sorry. Okay. So this is basically if else. If number is 2, it's going to return 2. If number is 1, I mean if anything else, it will be. So let's see if this passes. Actually, we should have run the test. You can remember. So what could be the next failing test? 3. So now again we have to run the test. Obviously it failed. I think I can just give me a minute. I just don't want this sidebar here. So in Xcode, for the iOS folks here, from Xcode we have a behavior. I think we can undo it. So from now on it won't pop up again. Yeah, it doesn't come, right? So what is the minimum code? Again, I'm going to do something like if number is equal to 3, just return 3. Ah. It's fast, right? But this looks ugly. Now we are in green state, but this looks ugly, right? So we shall refactor it. I think it's time for us to refactor this. Sriram, are you following us? Okay. So in Swift, we have a function called string. Repeat character of n times. And I hope I can remove all these codes. It's not required now. Let's run the test again. All 3 passes. You can clap it loud. So the 4th test case is 4. So the minimum code that I'm going to write now is like again number. Huh? Yeah, I basically told like every time you fail the test case, then fix the test case you should pass. Saying you did run the test. Yes. Yes. Kata. I'm still getting it that way to Okay, so we have a failing test now, then the next phase is return 5. I think that should pass our test. So the next test case should be 5, and I should run the test now, so that we are in a green phase, and I'm just going to follow the same thing, the minimal code that is required to run to make the pass failing test pass. Let's try and run. Yeah, this passes. We'll test for 7 this time. 6 or 7? 7, not 9. No. 6. Huh? Yeah, that's how it should evolve, right? So, so what? So the expected output is this, but we got something this. Yeah. So I think to now we have to write the result. Equal to, I'm going to append sum plus equal to. So will it pass? Let's run. It won't pass. Why?
You have to subtract 5.
Let's try. I'm confident about my code. Where? Oh,
You have to subtract 5 numbers.
okay. So Swift don't also in Swift this is considered to be a constant. So for that I think we have to do something like this. Number is equal to number. Now this is a variable, so that I can change now. Equal to what should I minus 5? So will it pass now?
Yeah.
Still fail.
Still failed. Yeah.
Yeah, it passed. So let's quickly test for 8. Will it pass?
Yeah.
Passed. Okay, let's test for 11. So 9. The Roman numeral 9 is 10. Then that should fail, right? Should fail. So I can quickly copy this and paste here. If it is equal to 9 or greater than 9, I'm just going to return. Yeah, I can do that, but let it be 9.
But for 10K,
Yeah, it passed, right? It passed. It means it ensures that all other test cases also
yeah.
passes.
So we shouldn't think the next step. Now when you think of 10, this will definitely fail, right?
Yeah, yeah, fine. We can refactor it anytime. I mean, when it is green. Okay. So when you see there is a duplication, when you obviously see there is a duplication or code smells, then it's a time for you to refactor when it is a green phase. Yeah, I see. I do see that there is a repetition or smell of code smell, but I'm just waiting for a generic structure pattern to identify. So this won't pass for 10, right? Yeah, it passes.
19.
19. Don't you think any other will be failing? No?
I think
Yeah, it passed. Okay. So let's quickly check for 20. Yes. Yeah, sure.
yeah. Then I would do it. I wouldn't. Uh, it's not as idea. What we did is put a test and then did it, right? I would first, what we would do is think of all the things and then might miss cases that we may be.
Okay.
But why do you think it is there cases? Because we may not come up with the place by thinking of the solutions. Right? We may not think in that manner. Maybe when writing the tests, we can think of such cases that might occur. Like here we're trying to break the code. Rather, when we're writing the solution, we're not breaking the code, we're just trying to solve it somehow.
You are making it very tiny.
Also, you are not thinking of multiple steps. Right?
Yeah, we are just making a tiny.
One step at a time. So you're totally translating things. I mean, you're basically things, removing the processing things that you would want your head to write the code. Yeah. And attack the problem. And the good thing is we have the safety net of all these tests. So whatever tweaking that I do with the code, there is a confidence level that it will be caught if something is breaking.
Yeah.
The building of this test,
So
all possible scenarios and conditions,
edge cases.
that helps. Like,
Yes. So for that, I think it's better to yeah, that's what it's one of the benefit of TDD. Following TDD, we will actually run through our requirements and have a better clarity of understanding. So what is test actually? Test is a behavior of what our code should do. It describes the behavior of what our code should do. So for that, I think we should have a better clarity and better understanding of our requirement. Then only we can even split the things up.
yeah. Otherwise, what happens after the solution, we will only have happy path test cases.
Yes.
I'll not think of writing these many combinations.
Yeah.
And then at some point something breaks, we say, oh, that corner case,
Yes.
maybe I did not check for 20 or 90.
Yeah. So sometimes what we will do is like in our normal, maybe in the behavior driven development, I'm not sure about that, but say we will write a test which will make, I mean, the test code pass. So I mean, we will write a test which will actually.
We know what it is doing, so
So
we'll write a test
yeah,
which just exactly.
what yeah, something like that.
And the challenge here is the time, right? So that is the trade-off. On the long run, it is beneficial. But again, here we're learning how to do things.
So his question is time.
Because there is a barrier for entry into the general.
Yeah, we started that, yes. See, we have a team of 100 people working in these projects, right? If someone breaks the system, then that time is very bigger than this.
Yeah, on the long run, obviously, it is.
The team has experience and team has the lack of motive is okay. But if they are running out of electrical performance, nobody thinks that I have a team which will come up with it.
No,
That's why we read later on when the code actually breaks, fix that, it might
after
take.
the product engineering, like suppose our employee
Yeah, running.
goes this way, then some mistake is in back this way.
Let us complete this. Okay. So to make this test pass, I think so the only simple thing that I can do is like replacing this if with while. So that should make our test pass. So quickly we can test it for 24 or what is the expected output? Do this. Okay, that failed. Was expecting. Okay. So let me copy this just to get the pattern. I'm just going to do this and see if this passes. It's succeeded. Anyway, let's see. Yeah, even that works. So I'm also going to check whether if I paste this here, will it test will the pass. For the interest of time, I'm just making it faster. Yeah. So here, even this should run. This also.
So you call this the
Like more test cases, right?
Yeah.
You can make it more interactive by trying to understand how people. I think everyone makes it as one gives us the delivery.
But they are not following.
We all know that we have to eat very good food. But we still continue to eat,
Bad food.
So maybe let's have a discussion, right, as why
Yeah.
we'll make it interactive as once
stopping us from doing it, or what's enabling us
I
to do
think
it?
we can.
Yeah, we can.
Yes.
finish it.
So I think you can
Yeah.
just.
One thing is like when you have, this is okay when you have just one test tube, when you have these many tests. In our code base only, if you see, there'll be like some 5,000, like 6,000 tests there. When you have to run all those for every change that you make, does it make sense? Or what do you?
So that's where like modularity.
1 second. So let's break for snacks and make it informal discussion so that plus people can answer. It's already 5:15. Yeah, I think anything.
So let's. Yeah, one more slide that I have to. Benefits of TDD, I think you all should. This is the most important slide. We know. Okay. Abhima to read this.
Knowing is not enough, we must do, right? Willing is not enough, we must do.
So who is this guy, man? Yeah, super. Someone who is in sports, who doesn't know about who is the guy. He said, and I asked him the same question. He said that that guy who do. So we know what we are, what we must apply, and willing is not. So we must do. Therefore, we can continue our
This question maybe you can answer. Yes.